Agents here, agents there, agents everywhere. The term agent has become omnipresent in the AI field. But really, what is an agent? So a few months ago, Andrew Ng gave a talk on agents, identifying 4 patterns that are commonly present in agentic applications. The reflection pattern, the tool use pattern, the planning pattern, and the multi-agent pattern. So following Richard Feynman's motto, what I can't build, I do not understand, I decided to implement each pattern from scratch. During this series, we have seen reflection agents, we have seen how to implement tools from scratch, and how the React technique works. But today, we come to the end of this series, and we will cover the last of the patterns, the multi-agent pattern. Ladies and gentlemen, welcome to the Neural Maze. Hello everybody, welcome to a Neural Maze. So this is the last video, sadly, of the Agentic Patterns from Scratch series. Today we are going to explore the multi-agent pattern, the last pattern of the 4 agentic patterns as defined by deep learning AI. In previous videos, we watched the reflection pattern in action, also the tool use pattern and the planning pattern. I encourage you to watch these videos if you haven't. I will leave a link, by the way, in the video description. And today we are going to learn about the last pattern, the 4th pattern, the multi-agent pattern. In case you are not familiar with this pattern, and in case you haven't used tools or frameworks like AutoGen, CrewAI, or even LangGraph, I will give you like a very quick summary about this pattern. But basically, what this pattern tries to achieve is to divide a task into simpler subtasks that are executed by different agents. So each agent is going to adopt a role. For example, one agent could be a software engineer, another agent could be a project manager, and another agent could be the CTO of a company. And each one of these agents are going to solve smaller tasks. Okay, so when all the smaller tasks are solved, then we can estimate, or we can say that the bigger task is going to be solved by the crew of agents, by the multi-agent application. Okay, so this is basically the approach. Remember that in the React application, in the React technique, we have an agent that has at its disposal a lot of different tools, and it can choose between the different tools. In this case, we are going to make the agents like smaller, like dumber, and each agent is going to be assigned to a specific task. Okay, that's basically the approach. I wanted to mention CrewAI, as I was saying, because maybe you are not familiar with this framework, but I've done a couple of videos about this framework previously in the channel, so take a look if you want. And now we are going to get into the Jupyter Lab, Jupyter Notebook, as always. And yeah, I'm going to to explain in a bit more detail what I was saying before. So what's my approach today? What am I trying to achieve with these videos? So when I started implementing the multi-agent pattern, I was going to follow the same approach as in previous videos, like doing a very simple, a very scrappy implementation in the Jupyter Notebook, and then teaching you how to implement it the good way or the proper way in VS Code. But today I'm going to do something a bit more different, and I wanted to make something more elaborate from the beginning. Okay, that's what I've been working on, like a minimalist version of CrewAI that draws inspiration from some of the key abstractions in CrewAI, particularly the crew and the agent. Okay, we will see them in detail later, but just to let you know. And apart from that, I also wanted to draw some inspiration to borrow some ideas from Airflow's design philosophy, using the right shift and the left shift operators. By the way, if you don't know what Airflow is, it's the orchestrator, one of the most famous orchestrators, and it lets you define the dependency between the tasks using the right shift and the left shift operators. This operator right here. Okay, and in my implementation, I'm going to borrow this idea. I'm going to overload this operator And instead of using tasks, instead of defining the dependency between different tasks, I'm going to define the dependency between agents. And instead of defining a DAG, like in Airflow, this DAG over here, we are going to define a crew, but just the same way, like defining one session in Python and defining the different agents and the dependencies between the agents inside that session, inside that crew session. Okay, right now it might be a little abstract, but you will see that it's quite simple when you see it in action. Okay, so let's get into the Jupyter notebook. Here you have, as always, the introduction, basically what I've been saying right now. You have also links to the previous lessons, to the first lesson about the reflection pattern, the second lesson about the tool pattern, and the third lesson about the planning pattern. And now we are going to get into the first class of this mini CrewAI framework, which is the agent class, okay? So as you can imagine, we are building a multi-agent framework, so it makes sense to create a class for the agent, for the proper agent. And as you can see, we just need to import the agent class from MultiAgent Pattern agent, and we can start using the agent. But let me show you the implementation first, because I want you to understand what we are doing under the hood. So we are going to go into VS Code, and I will show you how it works under the hood, okay? Okay, so in VS Code, you will see a new folder inside the Agentic Patterns folder called MultiAgent Pattern. And inside you will see two modules, the agent and the crew. Okay, we will start with the agent and then we will see the crew implementation. So first thing I would like you to notice is related with the imports, because even if we are importing this crew object that you have not seen yet, there are two abstractions that are important here that you have already seen in this series. The first of all is the tool. Let me get into the tool that we implemented in the second lesson of this series. And the second thing that you should be already aware is the React agent that we implemented in the previous video, okay, in the third lesson of the series. Remember that we were defining all this React system prompt in the previous video, and we saw how the React technique could be implemented in very easy steps, okay? So yeah. This agent is going to be based both on the tool, because an agent can use multiple tools, and on the React agent, because under the hood, this agent class is going to be a React agent class, okay? Okay, so let's get into the init method, and as arguments, we are going to pass the agent name, the backstory, and if you have worked with CrewAI previously, you should be really familiar with this naming, because it's basically the same. The backstory is like a background for the agent, and in some tasks it might help. It's very similar to the system prompt when you are dealing with a bare LLM. Then we have the task description, which is the description of the task assigned to the agent. The task expected output. This is becomes really handy when you want to define a very specific output for the task, which is the expected format or content of the task output. Then we have the tools, which is a list of tools. And remember that these are not CrewAI tools or LangChain tools or LlamaIndex tools. These are the tools that we defined on the second lesson of the series, okay? And finally, we have the LLM. In this case, I chose this Groq model, Llama 3.1, 70 billion versatile, and it works very well. So that's the reason why I chose it. Okay, so as attributes, well, we define the name, backstory, task description, task expected output, and the React agent, importing the class that we talked about just before. Now, if you keep scrolling down, you will see two attributes, the dependencies and the dependents. The dependencies, I mean, if you think of a multi-agent application, multiple agents related with each other, the dependencies are basically the agents that this agent depends on. Okay, so if these agents that this agent depends on have not run successfully, then the current agent is not going to run its task. Okay, and the dependents are basically the inverse. So they are the agents that depend on this agent. So if this agent, this current agent, does not succeed, then the dependents are not going to be triggered, are not going to be run. Then you have the context, which is basically the output from a previous agent. Okay, so imagine that this agent, this current agent implemented by this class, depends on another agent. The context is going to be the output from the previous agent. Okay. And then you have this weird stuff about register agent. This will make sense when we explain the crew, but basically the crew in this micro framework is going to be treated as a session. Okay, so you define a session, and inside this session, you're going to define the different agents belonging to the crew. So what is happening here is that if we have a crew, if there is a crew active, then this method is going to register the agent to the active crew. Okay, but that's something that you don't need to bother. And you will see it in action in the Jupyter notebook. Okay, so don't bother about this because it's a bit weird, but it made sense to use this session. Okay, this crew context, as you will see later. Okay, we keep scrolling down, and you will see a lot of shift methods, the right shift, the left shift, and unrelated methods that basically allow you to use, let me go to this is something that we haven't seen yet, but basically allow you to use these operators, okay? The ones that we were talking at the beginning that were borrowed by Airflow philosophy and that define the dependency between the different agents. These are the right shift and also the left shift, okay? The left shift operator. But I mean, in my case, I've never used the left shift, I think, so I will stick with the right shift operator, okay? Cool. So yeah, as I was saying, all of these, the right shift, L shift, etc., are related with these right shift and left shift operators. And then we are going to also the add dependency and add dependent, which are basically ways to define this dependency between the different agents. It's not something that I think we should invest a lot of time in. You can get into the code and see how it is implemented, because it's you will see that it's really simple. And now we get into the receive context. And this method is used for receiving context from another agent. So suppose one of the dependencies of this current agent has been successfully run, and we have an output from the previous agent. Okay, so this receive context method is going to take that output and allocate that output, that string, into the self-context attribute that we defined at the beginning of the class. Okay, here. Of course, if the agent has no dependencies, then this context will be an empty string. Okay. Then we move into the create prompt, because even if we are dealing with React agents, we need a prompt to pass to the agent. And in this case, this prompt is going to be composed of several information, but the most important one is the task description. That's something that we pass to the init method, if you recall. The task expected output, that's something that we also pass to the init method. And finally, the context. And this context is basically what we spoke about here in the receive context and the context attribute. Okay? Yeah, that's basically a prompt. And then we go into the main method, which is the run method, that simply creates the prompt that we have seen here with the create prompt method. And then it's going to run the React agent with this prompt, with the prompt that we have generated with the previous method. Finally, because this is not over, we need to pass this output to the dependents. That is, remember, to the agents that depend on this current agent. And that's the reason why we are going to loop through the dependents list, and we are going to call the receive context method for all the dependent agents. Okay? So that the output of this current agent is going to be allocated as the context for the dependents. Okay, I know it's a bit tricky, but when you think about it, it's quite simple. And we will see it in action with some examples, and you will see that even if the implementation might seem a bit difficult, it's really simple, and the application and the interface is really clean and easy to understand. So yeah, just wait for a couple of minutes. Okay, so yeah, we now understand how this agent behaves, and now we are going to see some examples. Okay, so remember that we were going to import the agent class. We have already imported that, and now we are going to create our first agent with this new framework. The name of the agent is the poet agent. The backstory is that you are a well-known poet who enjoys creating high-quality poetry. The task description is write a poem about the meaning of life. So I was feeling philosophical when I created this demo. And the task expected output is just output the poem without any title or introductory sentences. Okay, so let's create this agent and let's run the agent. This, remember, is a React agent, but it's really simple because it has no tools. So it just it's like an input-output prompt, basically. I mean, you give a prompt and the agent responds with the result, but without any tool involved. Okay, so in realms of existence, we wander and roam, blah, 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 searching for answers to an eternal home. So yeah, very beautiful rhyme. And let's get into something else. So we can see that this works for a very simple example. But now let's try something else with tools. Let's create an agent that has tools assigned to it. Okay. And for this, we are going to import the decorator that we defined and we implemented on the second lesson of this series, the tool decorator. Remember that this works almost exactly as the tool decorator from CrewAI, from LangChain, from LlamaIndex, etc. It's basically the same. Okay. So the tool I'm going to implement is called write string to txt. And as you can see, it's a very, very complex function because it takes a string and a file name, a txt file name, and it writes the string into a file name. So yeah, incredibly complex, and we are going to define the agent. Okay, so in this case, the name is going to be writer agent. The backstory, I didn't know what to put here, to be honest. So you are a language model specialized in writing text into txt files, so forgive me for this. I mean, it's terrible. The task description is write the string. This is a tool agent into this file, this tool agent example txt. And the task expected output is a txt file containing the given string. And we pass the tool write string to text. Okay, so let's define the agent tool example and let's run this tool. Okay, so remember, if you remember the previous video, that we had this fancy login with Colorama. We have, first of all, a thought, an agent thought. I need to take the given string and write it to a txt file with a specified name using this tool. So it makes sense, write string to txt, and the tool called dict is going to use this tool, write string to txt, and the arguments string data is, this is a tool agent, so yeah, and the text file name is tool agent sample txt. So it makes sense. And if we go to, yeah, here we will see this incredibly complex txt file with the string, this is a tool agent. So as you can see, our agent has successfully generated the file. Okay. So this is basically the same that we saw on the previous video. So now let's get into the dependencies, which is one of the key concepts, one of the key parts of this multi-agent pattern. So we are going to define two agents in this case: a poet agent, same as before, and a poem translator agent. This is a poem an expert translator, especially skilled in ancient Greek. The task description is that this agent has to translate a poem into ancient Greek, and the task expected output is just output the translated poem and nothing else. Okay, so let's define the two agents, and this is the cool part. Let's define the dependency. So in this case, agent 1 is a dependency for agent 2, or agent 2 is dependent of agent 1. Okay, so let's define the dependency, and now if we plot the attributes that we saw in VS Code dependencies, dependents, dependency, dependence, we'll see that agent 1 has no dependencies. It's an empty list, but it has one dependent, the poem translator agent. And agent 2 has one dependency, the poet agent, but no dependents. Oops, sorry about that. No dependents, okay? Now, the cool thing is that if we run agent 1 now, we should expect that agent 1 output is going to be parsed as the context for agent 2, okay, as we saw on the code. So if we run agent 1, in whisper winds that gently sway, a mystery unfolds each passing day, blah, blah, blah. If now we print the context of agent 2, you will see that the poem translator agent received context is in whisper winds that gently sway, a mystery unfolds each passing day. So it's working. It's working. The context for agent 2 is the output for agent from agent 1, sorry. Okay, so now if we run agent 2, we will expect this to use the system prompt, and remember this system prompt. And in this prompt, remember that we were passing the context. Okay, so this agent is aware of the poem generated by the previous agent. All right, so this is the translation. I don't know if you are experts in ancient Greek, but I am not. So yeah, let's suppose this is okay. But in the final example, I will be translating everything into Spanish. And since I am Spanish, I will be able to check if the translation is accurate, okay? So yeah, let's get into the crew. The crew, remember that it's like our DAG in Airflow, our orchestrator, okay? So let's get into VS Code again. And in this case, we are going to check the crew class, okay? The crew class has one argument for the init method, which is a list of agents. And then it has a couple of methods, the enter method and the exit method, that are used when defining a session. By the way, if you are not aware of this session or context, what I'm referring to when I speak about these concepts is basically this, okay? This with as keywords that let you define a context where you are creating all the agents, and all of these agents are going to be assigned with this context, okay? That's basically it. And we need all of these fancy methods, okay? I'm not going to get into details here, but you can check the code and you can modify whatever you want. But yeah, this enter and exit are for entering the context manager and exiting the context manager. And then we have this current crew attribute that we need to keep track of the active crew context, okay? And we will need that because remember that on the agent, we have this crew register agent. So the agent, if we call this, is going to be assigned to the active crew. And that's something that we are going to track by this current crew class attribute, okay? That's basically, I know it's a bit tricky, but I needed this for the interface of this framework to be easy to understand and to work with, okay? Apart from that, we also have one method, which is the add agent method, that adds an agent to the agents list that we defined on the init method right here. We have this register agent that, remember that this is the agent that we were calling from the agent class that assigns or registers this agent into the crew context manager. And then this is the cool part. Maybe some of you have studied computer science or know about basic data structures and algorithms, etc. So this is a very well-known algorithm for sorting graphs. And I needed this to decide the order in which the agents are going to be run. Okay, so the agents are structured in a DAG, in a directed acyclic graph. So I needed a way to sort all of these agents, okay, and to run them without any collision in the dependencies. And that's basically what I'm doing here with this topological sort. This is something that is going to be called whenever we are going to run a crew. You will see that later on the run method. This plot is a very handy function that I will show you in detail on on the Jupyter Notebook, we will see how to plot all the DAG, or the graph that we are defining with the different agents. And it's using GraphBiz, by the way. And finally, the run method. The run method, it's going to apply, as we were saying, a topological sort. And this topological sort is going to return a list of sorted agents. This agent can be run with a for loop. I mean, we can iterate of this sorted agents list, and we are not going to end up with any kind of problems with dependencies. Okay, that's basically what we need, this topological sort. And we are going to use this Colorama fancy print function to make things much more easier to understand and to visualize in Jupyter Notebook. And that's it. So we will see the crew in action in Jupyter Notebook right now. All right, so first of all, let's import the crew class, okay? From MultiAgent Pattern, crew, import crew. And now let's create the context, the crew context with crew as crew, and we are going to define 3 agents in this case, okay? We are going to define the omnipresent poet agent. Then we are going to define a poem translator agent, which is a bit different than before because it's going to translate into Spanish. As I was saying, I'm Spanish, so we will have the chance to understand and to check if this translation is okay. And finally, we are going to get into the third agent, the writer agent, which is going to take the Spanish poem and write it into a TXT. We are going to use the tool that we defined. And there you have it, this beautiful graph-based diagram. So we have the poet agent, the poem translator agent that depends on the poet agent, and the writer agent that depends on the poem translator agent. Okay, so you can see like all the relationship in terms of context, in terms of the output of one is the input for the other one, and dependencies and dependence. Everything is condensed into this diagram at the end of the day. Okay, and I think it's much simpler to see all of these dependencies with these diagrams than to getting into the VS Code implementation and checking all the add dependencies, right shift, left shift, because it's a bit messy and difficult to understand. But if you have in mind that at the end of the day, this DAG is exactly what we are trying to implement, it makes things much simpler. Okay, so we've just arrived to the last cell of the Jupyter Notebook. We are going to run the crew and see how it goes. So the first agent, the poet agent, is going to generate a poem in English. Then the translator agent is going to translate the poem into Spanish. So let's check the English poem. So in the grand tapestry of time and space, a thread of existence with displays. And yeah, in Spanish, en la gran tapicería del tiempo y el espacio, un hilo de existencia teje su lugar. So yeah, it's an accurate translation. And finally, we are going to see the last agent, the writer agent, that is going to use the writer string to text tool and write the poem in Spanish into a file. And the file is called poem.txt. Okay, so if we go to the Explorer, yeah, you will see the poem in Spanish written into the poem.txt. So this is everything for today. I hope you have enjoyed this lesson. In my opinion, this is the funniest lesson because we have put into practice all the patterns that we have learned in previous videos, the React agent, tools, etc. And it's really cool to see how all these agents can collaborate and can interact with each other to solve tasks. Of course, this is not a very complex task. I mean, it's just a sequential series of subtasks, and they are, really simple. We are just generating a poem, translating the poem, and writing the poem into a file. This is something that we could achieve with just one agent, but I think that it illustrates well how these multi-agent frameworks like CrewAI, LangGraph, or AutoGen work under the hood. So yeah, I hope you have learned something new. I hope you have enjoyed the video. As always, if you like this content, it would really support me if you click the like button or subscribe to the channel. I would really appreciate that. And yeah, this is everything for today. I hope I will see you in the next video, and until then, happy coding.